Okay, Calc, we're back. Part 2. We're going to do some implicit differentiation. So write down this equation. 3x squared minus 4y squared plus y equals 9. And when I'm looking for the derivative, I'm going to find dy dx. So I start from the left and differentiate to the right and with respect to x. So the first one, since it has the x value, the x variable in it, we're going to get 6x. We take the derivative. Over here, it's going to be similar, but since it's y, we do negative 8y, but we have to use the chain rule because here, on this term, we have 6x times the derivative of x, but that's 1, so I didn't even mention it. But here, because the value is y is representing an expression in x, so we have to follow by dy dx. Remember that step in implicit differentiation? So we do negative 8y dy dx, and this is a 1 dy dx equals 0, the derivative of 9. So we recall then, since we're looking for dy dx, these two terms have dy dx in it, so we're going to move this one to the other side. So moving it over here, I get minus 6x. I'm going to factor out the desired term dy dx, and that leaves, I'll put the 1 first. It's more visually pleasing. And then I'm going to divide both sides by that. So I get dy dx equals 6x, and I'm going to change the order. Dropping the negative sign, I will apply that negative to the bottom, so it'll make the opposite signs appear on these terms. So 6x over 8y minus 1 is the best form. Alright, so keep that in mind, and we'll do one more. This time, we are going to find the second derivative. So I'm going to give you a different one. Y squared plus 2y equals 4x squared plus 2x. So go ahead and find, the command this time is find the second derivative, which is going to be represented by this symbol. So let's just read the second derivative of y with respect to x. So that's what we're looking for. So go ahead and turn off the camera or pause and find the first derivative just like we did on the previous example. And then I'm going to continue with not showing you all the steps, but confident that you will agree with my final step for the first derivative. So find dy dx by integrating, differentiating from left to right and getting all the terms with dy dx on one side and every term without dy dx on the other. Factor out dy dx and divide. So doing all that, did you not get dy dx equals 4x plus 1 over y plus 1? Alright, I'm sure you did. Alright, I didn't show you the in-between steps, but I am confident you can get there. Alright, now I am starting here and I want to find the second derivative. So I'm going to take the derivatives across from left to right. So I take the derivative of dy dx and I get the second derivative. And I'm going to differentiate this side. And it would be the bottom times the derivative of the top. Oops, what am I doing? The derivative of the top minus the top times the derivative of the bottom. The derivative of the bottom would be 1 and then dy dx. all over the bottom squared. All right, so the step that you may not remember, but I hope you do, is we're not finished until we actually substitute an expression in for dy dx. And here it is. We know this equals dy dx. So I'm going to substitute 4x plus 1 over y plus 1 right in there. And that's still over y plus 1 quantity squared. All right, when I have a denominator in the numerator, I like to get rid of it. So I'm going to multiply everything on the top and on the bottom. I'm going to multiply the top by y plus 1. Do you see? I'm going to clear that by doing it. And the bottom, I have to do the same. All right, so in order to do that, this times this becomes y plus 1 squared times 4. So I multiplied this times that, and then this will cancel that, leaving only the top. All over the bottom now cubed. All right, so we should clean it up, and to clean it up, I may multiply out the top and multiply all this out on the top and see what shakes out. Let's see if I have any room over here to do that. Not sure it'll show up. I can't go much lower. I can, let me erase everything except that last step so I have plenty of room to work with. Alright. And this can go. And this can go. Alright. Nothing's going to stop me now. Alright, so when I square, so this is dy, a second derivative, written like that. So squaring y plus 1, I get y squared plus 2y plus 1 all times 4. So this becomes a 4y squared, this becomes an 8y, and this becomes a 4. Alright, so that took care of that. Now this is the minus sign I'll grab in a second. We get 16x squared. We get 4x and 4x, 8x, and a 1. All that is multiplied by this negative sign, so I'll go and change all the signs as we go. Distributing the minus sign, and I'll come back and combine like terms in a minute under that wavy line. On the bottom, I'm going to leave y plus 1 quantity cubed. Alright, so on the top, I get 4y squared, which won't combine with anything. 8y won't combine. I have a 4 and a minus 1, so I'll make that into a 3. 16x squared doesn't combine, and 8x all over y plus 1 quantity cubed. That is indeed your second derivative. So, alright, hopefully that brought back good memories, and if they weren't so good, maybe they're better now. Alright, it's always better second time around. Alright, that's all for tonight, and hope this review is helpful, and we'll probably only review one other topic because we have most recently done topics like finding second derivatives. We've done that sort of recently. We found all the things that we did in graphing, sketching curves, optimization we've done recently. So We've looked at concavity from the second derivative, max and min from the first derivative. So I'm not going to review the more current topics. So I think there's just one left, and then we'll dive back in to more and new exciting fields. All right, that's it. Good night.